My name's Ken Reed, and I'm the current president of the Heartland Renewable Energy Society. And I'm going to get to introduce a former president of the group, as happens to be my wife, Charla Reed. And I could read her bio, but I think I'm going to, since I have access to the website, I think I'll put her bio on the page with the video once we get this recorded. She's on several committees of the ResNet, Residential Energy Services Network, either chair of the committees or running subcommittees or whatever. I've lost track of how much she's doing. It's a lot. I think without further ado, I'd like to introduce my wife, Charla Reed. There you are, Mrs. Reed. Would you like to take over?
Okay. All right. Thank you. Yes. Welcome, everybody. Today, we're going to talk about energy codes, which can be a very dry subject, but we'll try to inject as much action into it as possible. We're going to talk about what are energy codes, what's their history, what's coming in the future, both nationally and in the Kansas City area. It's actually, there's some interesting stuff happening in Kansas City that you want to know about. So basically, we're going to explain what the residential energy codes are, how they've changed, what we can expect around here in the Kansas City metropolitan area. So I have an agenda, welcome and introductions, which we've done. I'm going to give you a brief history of the energy codes. What is the energy code that's been adopted by the Kansas City, city of Kansas City, the future of energy codes nationally and in Missouri, and we can have an open discussion. Oh, I also did want to say that some of these slides, I just wanted to thank Metropolitan Energy Center and Kansas City, Missouri. Some of these slides were subsidized in their development by those two organizations, and they are very active in codes at this point. So Ken talked a little bit about me. I do have experience in codes. I'm a preferred education provider for the ICC, which is the International Codes Council. I'm also an accredited training provider for ResNet, the Residential Energy Services Network, and then I hold a bunch of certifications that have to deal with all of this stuff. And as Ken said, I'm chair of the Standards Development Committee for Training and Certification on ResNet, and then I'm a member of the Standards Development Committee on Remote Inspection of Homes for the International Code Council and ANSI and ResNet, as well as a member of several other specialty groups that are working in the codes as well. So I've been inundated with this kind of a topic for about a year now, deeply, so, and even before that. All right. So what is an IECC? That might be the term that you'll see. And basically, that is the International Energy Conservation Code, which is a subset of the International Residential Code, which is a subset of the International Building Code. So we have the IBC, which is the International Building Code. And then the residential portion of that is the IRC, International Residential Code. And Chapter 11 of the IRC deals with energy efficiency. And then we have a subcode called the IECC, International Energy Conservation Code, as well, which is just the energy code. So what are building energy codes focused on? Well, just as you would expect, they're focused on insulation and air sealing. The codes talk about the R values of the insulation as well as how it's installed to be effective. They talk about air sealing and infiltration, which is air that from outside coming into your house, or air from inside escaping out of your house, which we don't want. We want to keep our conditioned air in our conditioned space. It focuses on places where air can leave, such as attic hatches, doors, fireplace doors, flues, recessed lighting, weather stripping is all included in the codes, as well as windows and walls, and there's all kinds of places for it to be sealed. The energy code also focuses on the systems, the heating and cooling and ventilation systems, as well as water heating systems. Focuses on lighting, windows and doors and skylights, so our fenestrations, and a bunch of other miscellaneous stuff like water pipe insulation, snow melt systems, pools, sunrooms, anything that uses energy or loses energy is going to be in the energy codes. So there are what are called paths to code compliance. And our first question that we ask is, does the project even have to comply with the energy code? A lot of jurisdictions in Missouri and actually around the country did not have energy codes for a long time. They just wrote those out of the codes and didn't pay attention to them. But during the Obama administration, any jurisdiction that accepted ARA funds, the American Reinvestment and Recovery Act funds, part of the requirements of accepting those funds was to adopt an energy code. So now a lot of places have adopted energy codes that didn't used to have them. So now we say, yes, most of our projects in the state of Missouri do have to comply with the energy code, and definitely in the Kansas City area. And then we have a path called a prescriptive path that you see there on the left. And that's basically, you get a bunch of tables in the code that say, here's your minimums that you have to meet. And it's either a pass fail. You meet it or you don't meet it. You meet this R value or you don't meet it. And then there's another path called the performance path, which has historically been listed in the International Energy Conservation Code, the IECC. And that's where a builder can prove that they are saving just as much energy on their walls and windows and attic and floors as they would if they followed the prescriptive path by showing how much it would cost. They'd have to simulate the performance using a computer and show how much the energy costs are. And if they're lower than the prescriptive path, then it's deemed as in compliance. So they document that compliance to get their plan review. And then there's testing and inspections that happen before they get their final certificate of occupancy to make sure that they do that. Well, in 2015, a new path was added called the Energy Rating Index path. And the Energy Rating Index path looked at the whole house as a system. So we're going to talk a little bit about the differences here between that path and the performance path in just a second. Another big thing that happened in 2018, prior to 2018, the prescriptive path was Chapter 11 of the IRC, and the performance path was the IECC, the performance path and the ERI path. But in 2018, Chapter 11 is now exactly the same as the IECC. We just, instead of having multiple energy codes, which were getting everybody confused, they put all of the IECC in Chapter 11, and now the IECC is just a separate book you can use to pull out to say, here's all the energy code items. So all of the paths are in both sets of codes. So basically, your prescriptive path means that you meet all the minimum required levels, that you have followed those tables and you have met those requirements. In the performance path, you get credit for testing the infiltration, so your air leakage in the house, the duct leakage, and mechanical ventilation efficiency. So if you can offset some of the insulation requirements by having tighter ducts or a tighter house, then you could prove compliance and you got credit for those things. But what if the builder put in energy efficient lighting or really energy efficient appliances in the house, or equipment, heating and cooling equipment that's very energy efficient, or solar on the house, which is going to save you some energy dollars because you're going to be generating your own energy. Well, none of that is taken into account in either the prescriptive or the performance path. So that's precisely why the Energy Rating Index path was put in place, because it looks at all of the items in the house as a system. All those interactions are evaluated, and the overall energy usage of the entire structure and all the items in the structure is taken a look at and determined how much energy you're actually using. So now you can get credit for all of these items. And it was actually a request of the builders to put in a path that gave them credit for what they were doing. So you can see complying with the energy code, there's lots of ways that it can be done. There's actually, under the prescriptive compliance, there's actually 3 different paths because one of them is you can use your U factor, which is looking at the energy efficiency of an entire assembly rather than just the amount of insulation in it. It takes into account insulation, wood or metal, whatever your studs are made of, the siding, the air film. It takes into account everything. It's mostly used for windows because it takes into account the windows, any window film, the frame, any spacing in the frame that helps stop heat transfer. And so a U value is the inverse of an R value. It's basically, so it's 1 over R equals U, and 1 over U equals R. So as your R value goes up and you become more resistant to heat flow, your U value is going to go down. So what we want is a high R value and a low U value. So you can actually prove in the codes your compliance using either the U value or the R value. Or the next one is the total UA, which is looking at the U value of the entire everything in the envelope, rather than just looking at walls or windows or doors or floors or ceilings. You're looking at the entire envelope and saying, altogether, all of this meets the requirements. Then the performance path actually has 2 options where you can look at the cost or you can look at the energy being used. And then we have our new path, which is the ERI path, the Energy Rating Index. And in the 2021 codes, they incorporated a brand new path for tropical environments, which we, of course, don't have here in Kansas City, but there is a new path in the codes. So now there's 1, 2, 3, 4, 5, 6, 7 paths to compliance in the energy codes. One of the things that we hear a lot from the HBA and from builders is that they're all focused on prescriptive compliance using the R value path, and they don't realize there's 6 other paths that they can choose to comply. So that's part of the reason we want to educate people on what's here. So if you hear things, you can dispel those rumors. So the energy code has an objective, obviously, of making more energy efficient buildings. So the improvements of the energy code from 1983 till now, you can see on this chart how it's gone, how the energy code has resulted in more and more and more efficient buildings. Currently in Kansas City, we're in a hybrid code of between 2009 and 2012 IECC. They adopted the 2012 IECC, but then amended some of the items back to the 2009 code. So we're in this hybrid place right now. Starting in July of this year, there's going to be an enforcement to the 2021 codes unamended. So that's a big jump. It's going to end up saving, let's see, we are probably at about between the 2009 and 2012 code at about 70%. And we're going to go down to, what's that, 42, so 41, so about 29–30% more efficient. It's a big jump, and it's going to help quite a bit. You can see that yellow dotted line down there is because in the 2021 code, and I'll talk about this, give you some more details, there's what's called a zero energy appendix. So any jurisdiction that adopts that, their energy use is going to go down to 0 because all the new buildings will have to meet 0 energy. And that's why you have that yellow line. So the energy code objectives obviously are to save energy, but there's some more objectives that energy codes result in. They do result in healthier buildings because we're having cleaner combustion, better ventilation. The codes are required mechanical ventilation, and poorly sealed building envelopes can allow pests, excess moisture, air pollution, and other stressors that can cause or exacerbate health problems. And so by having a good, tight envelope and an energy efficient building with good ventilation, mechanical ventilation, you're reducing your indoor air pollution and you're decreasing the incidence of asthma, allergies, lung cancer, COPD, other illnesses like that. So energy codes also result in healthier buildings. They also work on building durability. If you have a good tight envelope that's been verified, then you're going to have less air and moisture intrusion. less pest intrusion. Fire safety is something that's always required in a building, but it gets double checked when you're checking for energy efficiency as well, because the energy verifier is really focused on that envelope. And there's been several instances in my experience where I've found places that weren't sealed properly for fire protection, that they had to come back and seal it and make it safe for fire protection as well. Energy efficiency, we strive to manage the dew point. So moisture is the enemy of buildings. It can, Joe Steebrook is a gentleman who does a lot of energy presentations, and he likes to say that what we build today are self-composting houses. We allow too much moisture in the house and then it falls apart. So with energy efficiency, we have durability, we have better, more durable buildings. And actually there are home insurance companies that will provide a lower insurance rate to homes that are verified as more energy efficient. They also focus on building resiliency. You're going to see a term a lot more often now called passive survivability, because we're seeing a lot more natural events happen, tornadoes and fires and droughts and floods. And if a house is well constructed and tight, we can actually survive in the house a lot longer if our energy goes out, or things like that, if we lose access to heating and cooling. So it increases passive survivability, the ability to stay in your home even when you don't have active heating and cooling and active energy, electricity. It lowers the demand on the grid, which you're going to hear a lot more about the grid these days, because we're trying to make it better across the whole country, make it where it's not so prone to being attacked, and where it can handle the increase in demand as people move more toward electric. So lowering the grid demand with an energy efficient house, and lowering exposure to event-driven price spikes. If your house is very energy efficient, then things like having your utility bills like they had happen in Texas, where they had the ice storm and then all of a sudden everybody's utility bills went crazy. If you're not using all that energy, you don't have to pay that much for it. So it helps lower that exposure. And one more item here, energy equity. Energy codes are focused also on energy equity. There's been studies that show that each additional $1 invested in energy efficiency avoids more than $2 on energy supply spending. So we have some, the ability, saving energy saves money for the people in the house as well as the supply chain portion of it. It strengthens financial security of families, because studies also shown that your second highest bill after your mortgage is your utility payments, your energy payments. So if you can lower those energy payments, you can afford a bigger mortgage, or you can actually pay your mortgage because you don't have to spend so much on your energy bills. It also helps with healthcare costs because the houses are more healthy. And this is particularly important for the lowest income urban residents, because as you make less money, and I actually borrowed a slide here from the Metropolitan Energy Center that they showed you on a previous presentation, that those who earn less in our communities obviously pay a much larger percentage of their income toward utility bills. And so the more efficient we can make housing, the more affordable we make housing. And Kansas City, Missouri is pretty highly ranked for energy burden for homeowners and renters, that they're spending an awful lot of their income on their energy costs. So what is the new Kansas City, Missouri Energy Code? Well, as I said, Kansas City, Missouri has implemented or has adopted the 2021 IECC, the latest and greatest energy code. What this means is that there are increases in R values expected, or decreases in U values, which we talked about before. There's also a requirement now in the codes, in the new code, that the R value mark has to be readily observable, or the insulator has to provide a certificate. You would think that that'd be something they'd already do, but it was found that it needed to be put in the codes because there's a lot of blown insulation, and the insulators are not standing behind the R value of the insulation they're blowing in. And now they have to provide a certificate that says, here's how much R value I put in. There's been a new definition for what is air impermeable insulation, because a lot of insulations were claiming to be air barriers as well as insulation. And now that's been scientifically determined and added into the codes, what actually constitutes an air barrier versus insulation, and what insulation can be considered an air barrier. The old codes had a term in there called mandatory, and on mandatory items, every path, we talked about all those different paths, each path that was taken had to follow all the mandatory items, even if they weren't, if they weren't following a prescriptive path, they were following a performance path, there was still items in the prescriptive path that were required to be done. However, it was confusing for some people. They didn't go backwards and look at all those items. And so a lot of the mandatory items were being missed and not actually being implemented. So now in the codes, they simplified it by just making a table of required items at the beginning of each of these path descriptions that says, if you're following this path, you must complete these items. And so the mandatory items are still there, but there's going to be a much higher probability that they will all be completed. There are additional energy efficiency requirements for all of those paths. And they've included now a solar ready and zero energy provisions in an appendix. So I'm going to go over those and you'll see what those are. I know that's of most interest to this group. And there's new language in the air barrier, air sealing, and insulation installation component sections. There was a lot of focus before on insulation values, but not a lot on air sealing and what all needed to be air sealed. So now there's more focus on that because it's highly important if you want your home to function correctly, that it be air sealed as well as properly insulated. The maximum air leakage rate is put in place now for all compliance paths. As I said before, you got credit for air infiltration on the performance and the ERI paths. But when those were measured, there was no requirement for how tight the envelope had to be. They were just, it is what it is, and it fits into the formula of how much energy you're using. But now in the 2021 code, you can't go more than what's called 5 air changes per hour. And so in any path, no matter what path you use, you can't have a real leaky house. The ducts have to be tested as well to see how leaky your ducts are, regardless of what location they're in. There used to be an exception if all the ducts were in the envelope, were inside the house, but that now they have to be tested no matter where they are. And insulation for ducts changed based on which location they're in. There are eave baffle requirements in the attic to keep insulation in the attic on the edges. There's attic hatch design requirements, which weren't in there before. Ventilation system fan efficacy requirements. When mechanical ventilation was written into the code back in, I want to say 2009 or 2012, one of those was where mechanical ventilation was required for all paths. A lot of ingenuity went into deciding how do we incorporate mechanical ventilation into our homes, and some of the methods of incorporating that mechanical ventilation ended up using fans that used a lot of energy, and so it ended up really impacting the energy use of the building. So now the ventilation system fans have requirements of how efficient they have to be. Lighting has changed. They changed the definition of lighting efficacy because now we have, instead of just incandescent and compact fluorescent lights, we have LED lights. We have more and more efficient lights. So they changed the definition of the lighting efficacy. and are requiring 100% of efficient lights be put in, as well as some controls. We'll get into a little more detail on that. And there's a new hot water distribution compactness factor. I'll show you some more about that too. So what are these changes? This is the U factor and R value changes for our region. You can see in the green parentheses, those are what are in the code today in Kansas City, Missouri. That's what's required right now. And then the black ones are what's coming in 2021. And if there is no green, then they didn't change for 2021. It's the same as what it was. So one of the biggies here, you can see that the ceiling R value, currently we require R49 in the Kansas City area. It's going up to R60. Wood frame walls currently require R13. That's increasing to require 20 continuous, or 13 in the cavity plus 10 continuous, or R30 in the cavity, or 20 plus 5 continuous. So it's and these are all prescriptive path items. So this is just that one path, the prescriptive path. If a builder wants to follow one of the other paths, the performance path or the ERI path, they can continue to put in R13 walls as long as they can prove that they're saving enough energy somewhere else to make up for that. So it's only a requirement under the prescriptive path. Our mass wall R values, which is going to be your concrete walls, your foundation walls, changed a little bit, increased slightly, and the slab insulation depth, they added 2 more feet to the slab insulation depth, because you can lose a lot of heat out of your slab if it's not insulated deep enough or under far enough. So obviously increased thermal efficiency. And the big one that one of them that the builders are complaining about is the R49 to R60 insulation in the attic. Now the code does say that you can have R49 in the attic, and that qualifies as long as it is full height and goes all the way over the top plates at the eaves. So I'm going to show you here. Can you see my cursor, my arrow? Yeah, okay. This is a typical top plate on a house. The roof is coming down. It makes this little, it's called a bird's mouth thing. It's to make a little point down here at the end. This is a 3.5 inch, 2x4. So you can see that above this top plate on the exterior wall, you have basically 3.5 inches of height, which is not enough to get an R49 all the way over the outside wall. You really don't even have 3.5 inches, because you need to have a baffle in here so that any of the air coming in through the soffit goes over the insulation and doesn't blow it away from the wall. This picture up here kind of shows your air comes in the soffit, goes up through the baffle and over the insulation. So what the code is trying to promote is this kind of a wall, which is called a raised heel truss. So you can see on the outside wall here that instead of that little point coming all the way down, the roof has been raised up a little and blocking's been put in. So now that R49 insulation can extend all the way out over the outside edge of your wall. And so we can still do R49. It just has to extend all the way out to the outside of the structure. Now, the other thing that has raised a lot of concern is having an effective air barrier in the attic, which is a wind block or an air chute or an eave baffle installed in every bay and sealed. And that's, you can see here, here's that air coming in, going up over the insulation and out the ridge vent. The reason that needs to be there, and it needs to be in every bay and sealed, is because of a phenomena called wind washing. Wind washing is where the air comes in through the soffit vent and pushes the insulation away from the edge of the house. This is an infrared image showing that phenomena where the wind has come in and pushed the insulation away. So now there's no insulation in these blue areas. This house does not even yet have its certificate of occupancy. That wind washing was done just within a matter of a day or two after the insulation was installed. So from the time this house gets purchased through it's not going to have any insulation over the outside edge. That's why this is important. Here's what it looks like on the inside. And the reason that we want a baffle in every bay is you can see here's a baffle and it's working. The vent is actually in this bay and there's no vent in this bay next to it. So the baffle is working for the vent, for the bay with the vent. The air is coming up and over. However, air is not going to pay attention to that and say, oh, there's a baffle, I have to go that way. It'll take the path of least resistance, which is exactly what happened here, as it goes sideways through the soffit and comes out this area where there is no baffle and just pushes the insulation away. So that's why you get these marks here. I've got one more that's interesting. Here's one that it pushed the insulation away from a huge area. There was 16 to 18 inches of insulation right here. The next day, this is what it looked like, and you can see all the insulation blew over to the side. It just filled it up all over on the side and behind it. So the insulators came back, said, okay, we'll just add more insulation. They added more insulation, and the day after that, it was empty again. So we really have to block the insulation from being blown away. Otherwise, on the inside, here's what you can end up expecting. So this is a house in Kansas City that had wind washing, ended up having ice and moisture coming down in the corner where the insulation had just blown away from the wall. So there's a building durability issue for you right there. Okay, the air sealing in the new codes includes air sealing rim joists, which wasn't there before, slab foundations. We have to air seal all of these areas, the shafts, penetrations, and shafts and penetrations. There's added insulation requirements. Narrow cavities are now being addressed in the codes, which they weren't before, so that we're air sealing these cavities. It used to just be that the insulators would poke a bunch of air impermeable insulation or air permeable insulation into those cavities, which did not seal them and did not insulate them very well. Any garage separation, recessed lighting, and then plumbing, wiring, and other obstructions, air sealing requirements were added. And that's because of this phenomenon where we have interior walls that are leaking a bunch of air from the attic. These were taken just a few days ago, actually, a couple days ago. This is air coming down through that top plate, and here's the hallway, the interior hallway. All this cold air from the attic coming in through holes for plumbing and wiring and shafts and penetrations that are in the inside walls. Your inside walls become outside walls if they're connected to the attic with holes and penetrations. So those all have to be air sealed. And the new code has much more definition and requirements on air sealing to make sure that this kind of a thing doesn't happen. And in this one, you can see that, the wall is 45 degrees up here at the top. And it's 60 degrees down below. And the house temperature is set to 70 something. So those people are very uncomfortable because their walls are all cold. All right. Air leakage. The air leakage updated itself a little bit so that there's, as I said, a maximum air leakage of 5 air changes per hour, but also added some additional ways of calculating the air leakage that's allowed, and provided exceptions for attached buildings because they have sides or tops and bottoms that are against conditioned space, or smaller buildings, because there was some inequity in the amount of air leakage that was truly required or truly allowed in large buildings versus small buildings with the calculations. So there was some of those added. And then the prescriptive path has to requires an air changes per hour of 3 or less in our climate zone. The other paths can go up to 5, but 3 or less on the prescriptive path. Okay. Ducts. There's more definition for ducts and where they need to be insulated. Any ducts outside conditioned space, the insulation moved from R6 to R8 for larger ducts and R6 for smaller ducts, and includes all unconditioned spaces, not just attics. Any ducts located in floor cavities that are over unconditioned space, so that bonus room above the garage, they have to now have a continuous air and thermal barrier on the garage side or on the unconditioned side. Then it has to have a minimum of R19, separating the ducts from unconditioned space. Because if your ducts, get cold in the winter or hot in the summer, now that air that's supposed to be conditioned running through them is cooling down in the wintertime or heating up in the summertime, and you're losing all that good conditioning that you had. Any ductwork in exterior walls also has requirements now to have at least R10, separating it from the unconditioned space. The remainder of the cavity must be fully insulated, and it must have a continuous air thermal barrier on the unconditioned side, on the unconditioned side. Yep. Okay. Ducts have to be tested for leakage. There's no more exception for ducts or air handlers that are fully within the building envelope. The test has to be written and signed and provided to the code official. And now there's several categories of duct leakage that are allowed depending on when the test is performed and where the ducts are located. There is an allowance for a higher level of duct leakage if all the ducts and the air handler are entirely within the building thermal envelope and no building cavities have been used as ductwork. As building cavities used as ductwork tend to leak like crazy. They're very hard to seal. All the materials are made of all the parts of it are made of different materials that expand and contract at different rates, and so they don't stay sealed over time. So this is trying to promote the use of hard ductwork all in conditioned space. We have lots of methods of doing that now. It's just inertia that's keeping us from actually doing these things, because everybody's used to building them and putting the ducts in the attic or in a crawl space or under the slab instead of in the conditioned space. Ventilation system fan efficacy. That's what I said. The building has to have ventilation. The ventilation system fans have to be efficient. So there is a new table in the codes that talks about all the different kinds of fans that you might find in your house. Exhaust fans, supply fans, range hood fans, balanced ventilation fans, and even the air handler fan has requirements for how efficient it must be. And there's not an exception for an electronically commutated motor anymore, which was one exception for the air handler fan. But now there's just straight efficiency requirements for those fans. And all mechanical systems have to be tested to make sure that we're actually getting that ventilation airflow that you're supposed to have that good fresh air in your house. So ventilation systems are required. The code actually went so far this time around to require HRVs or ERVs in climate zone 7 and 8. The system fan has to be efficient and the airflow has to be tested. Best practice for our climate zone, which is 4 and 5, 7 and 8 are up and far north as you can go. We're in 4 and 5. Actually, Kansas City's in climate zone 4. 5 is the far north area of Missouri. An HRV is a good choice for our climate zone because we have dry winters and we have humid summers, and an HRV will help transfer the heat content of the air so that your exhausting warm air in the wintertime is warming up the cold, dry air that's coming in, and the exhausting cold air in the summertime is cooling down the hot air that's coming in. An ERV will also transfer that moisture, so it will actually add some humidity in the winter and remove humidity in the summer. So an HRV or an ERV are good choices, but an HRV works fine in our climate. There's also some changes to the water heating systems. There are so many different water heating systems in use in a house anymore that the codes had to update. And some of the main things that they're seeing is that a lot of our homeowners are putting in water systems that have circulation pumps in them so that they can have hot water when they want it, where they want it. A lot of the circulation pumps was a commercial thing that was used in hotels, and to make sure that all guests have hot water right away when they want it. They don't have to wait for, if they're up on the 8th floor, they don't have to wait for the hot water to come up from the basement. So now we're seeing a lot more of those in residential buildings. So the code requires that you have a pump with controls that can stop the circulation when it reaches temperature. So we're not just wasting energy circulating hot water. Has to control the water temperature. There has to be automatic controls. If there's automatic controls, then they have to be accessible. And if they're manual, they have to be readily accessible. So accessible means you can get to it with a ladder, or, there's some way to reach it, but it might take a little work. Readily accessible means you shouldn't have to have a ladder or anything. Just open a cabinet and there's your controls. So if it's manual, it has to be readily accessible so you can turn it on and turn it off very easily. Pipe insulation is now required in the new energy codes, has to be R3 or greater for water pipes. Domestic water, DWHR system, which is a domestic water heat recovery system, is what we're seeing up here in this top picture, where we've got coils wrapped around the pipes that are going down. And this one is an apartment complex, so there's 4 in a row, but the pipes coming out, these are drain pipes from showers, from sinks. So we're draining out hot water. Usually it's from showers that are we know we're going to have hot water. And the incoming water has copper that's coiled around the drain pipe. So basically, as the incoming water comes in, it's taking the heat off of the drain pipe for the showers and warming up for free before it hits the water heater. So we're warming that up. So there were some items added in the codes to make sure that we're not causing major pressure losses in the house by adding all this extra length of copper. So their pressure loss requirements are down here. All right, and then there's this new hot water distribution compactness factor, which it's actually for the prescriptive path. And it looks like this. It's trying to have builders think more about where is the water heater in connection with where are the hot water using appliances, so we can limit the amount of pipe the water has to go through before it hits the hot water using appliance. So this is a picture showing it probably from the codes. So it's looking more like a house in Arkansas or something than in our area, where you have a water heater in the garage. And if we have the water heater clear over here, we've got this great big area that the water pipes have to run to get the hot water to the sinks and the showers. But if we just move the hot water heater over to the other corner here, now we've got a much smaller area that we have to run piping to get to all of the hot water using appliances, which actually provides us a 5%, in this case, a 5% savings on the energy used for heating water. So the energy savings, hot water distribution system, in the proposed design, they've got allowances in the code for 5%, 10%, 15% even savings of energy for hot water that can be used to lower the energy use in the building and meet the energy codes. So trying to get that water use, the hot water generating item, the water heater, close to all the hot water using items so that we don't waste energy by piping water all through the house. Okay, lighting changed. The definition, like I said, for high efficacy lighting has changed. Our current code in Kansas City is that 75% of all of the light fixtures that are permanently installed have to be very high energy efficient. In the 2021 code, that increases to 100%. It's also included interior lighting controls. Interior lights have to be on dimmers or an occupant sensor in the rooms that are used the most during the day. Some areas do not require the controls, but there are areas where controls are required. And then exterior lighting also requires controls to automatically shut off during the day. And during the night, you can have a movement, motion sensor or daylight sensor is required on the exterior lighting controls. Then we have these additional energy packages. Part of the code, obviously, was to save energy. And there was a request that that options be provided for saving this additional 5% that we were trying to get in the new codes, so that a builder could choose what option worked best for them rather than having something required that they had to do on every home. So there's additional energy efficiency packages. The prescriptive path can choose from a list, which I'll share with you. The performance path can choose from that list or just prove they have a 5% reduction in energy costs. And the energy rating index path has to have actually an energy rating index that's 5 points lower than the one that's in the code. So every point is about a 1% savings. So the energy rating index path can prove their 5% by having a 5-point lower ERI. So the options are having enhanced envelope performance, which means that the envelope, the insulation and the air sealing in the walls, and the area weighted solar heat gain coefficient for the windows are 5% better than what's provided in the table. Or we can put in more efficient heating and cooling equipment, and this is the list of requirements for that equipment depending on what kind is being put in. A furnace and air conditioner, an air source heat pump, or a ground source heat pump. We can also put in more efficient water heating equipment, and those are the requirements depending on the type of water heating equipment. And the code has recognized that solar water heating is a very good idea. And if you have a solar water heating system, which provides at least 40% of the hot water, then that counts as your additional energy efficiency package that saves 5% on the energy use of the home. So there's a solar fraction allowed now for solar water heating. You can also prove it with more efficient thermal distribution duct system, which is putting all the ducts and the air handlers entirely in the building thermal envelope, or putting in a system that doesn't require ducts, because those save a lot of energy because you don't have the ductwork for them to leak through. And those would be like mini splits or multi-splits, something like that. Or if 100% of the duct system is located in conditioned space as defined by the new rules in the codes, because sometimes ductwork in the attic can actually be considered in conditioned space, which I will share with you right now. So in conditioned space means it's entirely within the continuous air and thermal barrier, or it can be located in a ventilated attic and buried deep enough that it is like it's in conditioned space. These are the requirements. It requires a lot less leakage to the outside, which is good, less than or equal to 1.5 CFM at 25 pascals per 100 square feet to the outside, which is about half of what is required, what is allowed normally. So if you have about half of the duct leakage and you have deeply buried your ducts in insulation with at least R19 above the ducts, below the ducts and beside the ducts, and the ducts themselves are insulated, then they can be considered in conditioned space. Okay. You can also provide additional efficiency with improved air sealing and an efficient ventilation system. So you have to have less than or equal to 3 air changes per hour plus an ERV or an HRV that has greater than or equal to 75% sensible recovery efficiency. So basically greater than or equal to 75% of that heat that is leaving the house is being transferred to the incoming airstream. Has to have a very efficient fan. Can't use recirculation as a defrost strategy. So if the HRV gets frozen, it's not using the inside warm air to defrost it. And if it's an ERV, it has to also have a high latent recovery moisture transfer, which is the humidity transfer of the air. Has to be able to do a good job with that. All right, so those are the options for a builder to choose to prove that they can save another 5% of energy efficiency in the 2021 code. They have a lot of things pick from, depending on the house and where it's being built and the design. Some of these will work better than others. They can pick and choose so they can make sure it's efficient and effective and cost effective for what they're constructing. Clean energy systems have a much bigger impact in the code now. The codes talk about photovoltaic systems, electric vehicle charging, and there's a solar ready and zero energy ready appendix. So with photovoltaic systems, this is an item that is taken into account on that energy rating index path, the ERI path. The codes state that the RECs, the renewable energy credits, are retained by the homeowner. They're not sold to the solar company or the utility company. They actually go to the homeowner. But photovoltaic impact on the energy efficiency is limited to 5%. So even if it provides more than 5% energy reduction to the house, the max that can be claimed is 5%. And the envelope has to at least meet the 2015 IECC requirements to get that credit of 5% on the PV system. Electric vehicle charging stations are also taken into account in that energy rating index path, and they are allowed to not be included in the energy use. So basically it's free energy for the house to charge up the car. You're not being dinged by having extra electricity being used to charge the car. That's being promoted as something that we want to have. We want to have electric vehicle charging stations. So it's not gonna cause something else to be more efficient to make up for that electricity. And then the two appendices, these are optional appendices, RB and RC. Solar ready is one of them, which the appendices can be adopted by a jurisdiction if the jurisdiction wants to. They're not part of the code. They're parts that have been written to be added in if the jurisdiction wants to add them in. So solar ready means that there's roof space that's been reserved for a solar PV system or a solar thermal system. That is the correct orientation to make it work. Has to be unshaded, and any roof load that might be had by putting on a system, with including the wind load, the point loads, there's a lot of engineering that needs to go in to make sure that the roof can handle a system. So since the solar ready appendix doesn't allow the solar system to actually be installed, the building has to be built to allow for that system to be installed in the future. So they need to make sure that the roof can handle the additional load. They have to reserve space for in the electric panel for the solar electric system, and they have to run the conduit from the panel up to the roof and cap the roof penetration so that in the future someone can just put panels up there and they already have the conduit to run the wiring down to the panel. It can be done really fast and easy when you're building the house. It's a little more difficult to put in after the fact. So having that conduit available is very important. The city of Kansas City, Missouri kind of adopted some of this appendix by they are requiring a conduit go from the panel to the attic at a minimum. It can go to the roof if it's capped, if it goes out the roof, but it can also just stop in the attic. And then they also have a second conduit run from the panel to the garage. They want to have the conduit to the garage as well to allow for a future electric vehicle charging station if one's not being put in. So that's the Kansas City amendments to the code. They amended to include conduit runs to the attic and to the garage. There's also a zero energy appendix, which is where a jurisdiction can require that every new home or apartment or every new structure, residential structure, be built to be zero energy. So it has to produce as much energy as it uses. And in order to do that, it has to follow the ERI path, and they have a lower ERI index that needs to be met before putting the renewables on. And then the final energy rating index has to be 0 at a maximum, which means the structure is producing as much energy as it's using, or it's using community purchased renewables. So it's signed up with a utility program that is only using solar or wind power or some other, some renewables resource. All right, so what's coming in the future for energy codes, 2024 and beyond? There's going to be a big focus on carbon. Carbon is going to be looked at as far as, because we know we've got increases, we've got problems right now with climate change, and carbon is a big problem with that, big part of that. So they're looking at the carbon in the energy provided both at the site and at the source. So there's going to be accounting at the site and the source, looking at natural gas versus electric versus other ways to get energy. Looking at operational carbon, so how much carbon do we produce when we're operating, and embodied carbon, how much carbon is used to generate these materials or to source these materials. So you're going to see a big focus on that. Definitely a focus on resiliency. How do we make structures disaster resistant? How do we increase passive survivability? Energy storage for both residential and commercial buildings is going to be a big one. Can you include enough storage in your structure that maybe you could help power your neighbors if the power goes out? Things like that. Distributed energy. Can we have a community center that has got all this energy storage and can provide power to the surrounding community, so that we have smaller grids in place and somebody can't take out the entire national grid in one fell swoop. And then focus on code adoption and enforcement. How do we make sure that these codes get adopted, and how do we support our code officials in enforcing the codes? Of course, you're going to see a focus on energy. They continue to look at the fan energy that's being used. You might see a mandate on the duct locations, no longer allowing ducts to be in an attic or in an unconditioned basement or crawl space. Providing credit for energy storage, for EV ready, limiting the peak loads that can be in a building. You might see those zero energy and solar ready appendices actually become part of the code in the future. Excuse me, probably not in 2024, but in the future coming up. And there's a big focus on electrification and making sure that we are ready for electrification, electrification of everything. Looking at the equity, compliance equity, I call it, which is basically the equity between all those paths. We have those 7 paths that can be used, as 6 in our area. Making sure that they're leveled out, that you're basically saving the same amount of energy no matter what path you choose. Currently, there are some backstops, which is where you can't go less. You can't have a lower R value than a certain code level. There are some that are seemingly punitive to some of the paths. There is an issue with the energy rating index path on mechanical ventilation that needs to be fixed, that they tried to fix in the 2021 code but didn't quite make it. It will be fixed in the 2024 code. Leveling the stringency requirements of each of the paths. And then there's a discussion about mechanical equipment efficiency. Right now, the code and all of history, the code has said follow the federal minimum mechanical efficiency requirements. Well, there's talk about, do we keep that as a federal efficiency requirement, or do we start moving it into the energy code as a place where we look at the mechanical system efficiency rather than having it outside the code and having to refer to that? So that might be coming into the energy code. And there's going to be additional efficiency option packages provided to save energy. So that's federal. What's happening in Missouri? What's the future hold for Missouri energy codes? Well, one thing you need to understand is that the ICC codes, the IECC and the IRC, are what are called model codes. They are provided as a model for jurisdictions to use or amend as they find appropriate. The local building codes that are adopted by the jurisdiction, that's the law. So no matter what the international code says, it's the local code that has to be followed. That is the law, and the code officials have the authority to interpret the code however they see fit for their local jurisdiction. Any energy professionals or third-party verifiers have to be approved by the local code official as well. So locally, as I said, Kansas City, Missouri has adopted the 2021 IECC with just a couple amendments there. But the state of Missouri has a new House Bill 580, which ignores Missouri's history as a home rule state. So the term home rule is something that we see in codes across the country, depending on where you are. Missouri is what's called a home rule state, which means we don't have a statewide energy code. What we have is codes per jurisdiction in the state. Each jurisdiction chooses what works best for its area. And the jurisdiction can choose what they want their codes to be. But the state is now trying to put in this House bill, which basically has 5 things in it that overrule whatever a local jurisdiction has. It prohibits any codes with wood frame wall cavity insulation greater than R13 be required in the codes. So they want to keep it at R13 for wood frame walls. It makes it illegal to have the effect of requiring the utilization of exterior continuous insulation. So all of those code items in the prescriptive path that said plus R5 continuous or plus R10 continuous would have to be gone. You can't require continuous insulation. It outlaws maximum air leakage rates less than 5 air changes per hour. So that prescriptive rate of 3 air changes per hour would be against the law. It would you'd have to change it to 5. So they want leakier houses, leakier, less insulated houses. It bans the requirement for ceiling insulation greater than R38, which we currently have R48. So we're already breaking the law if that's the case. And it requires the use of framed cavities as ducts or plenums be allowed. This is a really bad idea because it's been proven over and over and over again that using your framing, which is your floor cavities or your wall cavities, as a duct, you have tons of duct leakage. Not only that, but especially on the return side, what we see in our area is we see a lot of returns in the basement that are using floor cavities at the basement ceiling as a duct. Well, those leak a lot. And then you also have right next to there is a water heater and a furnace with flues. So what we do is we have our return air all coming from the basement because our ducts are leaking and sucking all the air out of the basement, which causes negative pressures in the basement and causes those flues to backdraft. And then what we have is poisonous air coming down into our basement, which is being sucked into our ducts and spread all over our house. So that's a very efficient distribution system for carbon monoxide, which is something that we really don't want to be breathing. But House Bill 580, the state of Missouri wants to require that we allow the use of ducts use of framed cavities in our houses as ducts. We also, if they're in the walls, we can pull a lot of air out of the attic, and you don't want to be breathing that air either. So it's not a good idea to be using cavities as ducts. And that's my soapbox item for the day. Okay. So House Bill 580 was introduced January 4th by Dan Hoax, I don't know how to pronounce his name, from District 54. Usually it takes a while to move a bill through and make it into law, but this one is being pushed by somebody because it was immediately referred by January 19th to the Government Efficiency and Downsizing Committee, because that's where you want to go for all this government overreach to be telling the whole state what they can and can't do. But so Government Efficiency and Downsizing got it on January 19th. They held a public hearing on February 1st, which was announced on January 31st. Actually, it was announced, I think, January 28th. They were going to do it on the 29th. They had a whole lot of written testimony and people saying they wanted to be there, so they had to delay it to February 1st. 93% of the public testimony, both verbal and written, is against this House bill. So people don't want it. But the committee went ahead and passed it anyway. 9-3, and then 2 people, one was absent, one abstained. So the committee passed the bill on February 22nd. And on February 23rd, it was referred to the Rules and Legislative Oversight Committee. The Rules and Legislative Oversight Committee already had items on their agenda for their next hearing, which is Monday, the 27th. But they went ahead and added this bill to that. They were asked to apparently push it in and get it past this committee. If it passes this committee, my thoughts are that it goes from there to the full House. And then it will be, if the House passes it, it will become state law. And about 120 jurisdictions will immediately be breaking the law because they have more efficient codes, energy codes than that. So the next hearing is February 27th. It's an executive session, so it won't be allowing any public testimony. However, you can look up the Rules and Legislative Oversight Committee on the website and send all of these people emails if you want to. I did. So that is House Bill 580. That's what's happening in Missouri right now. If that law passes, then St. Louis, Kansas City, a lot of the jurisdictions will be breaking the law and will have to change their codes. I have a feeling there'll probably be some lawsuits, but we'll see what happens. And that is where we are. So now I'm open to questions and discussions. I see there's some stuff in the chat.
Can I jump in a second?
Yes.
You also didn't mention if Kansas City is not allowed to have the 2021 code, all the money's coming from the Inflation Reduction Act that's supposed to help get these codes in place and pay for training to get building officials and energy professionals up to speed on the new code so they could do inspections. And the codes people want this because they can't necessarily keep up with all these new rules and regs, and they appreciate that a certified home energy rater can inspect on their behalf on certain things like the energy component of the homes. So all this will be disallowed in Missouri. I don't remember the exact number, but it's in the millions of dollars that Missouri will miss out on for having to be pushed back to basically the 2006 codes is what we figured. So really, it hurts the state badly in terms of, the monies we could get. But the committee referred to all these monies as a money grab, and it's not necessarily, they don't want the money given to the state for whatever reason. I don't know, except that we know that the builders are against it big time, the new codes. So I'll stop there.
Okay, well, I do see some questions in the chat. Yes, I will make the slide deck available. I promise. That's fine. It's also being recorded and going to be available on the HRS site to watch later if you want to. New city council candidates are repeating that the new code will result in increased housing costs and therefore less affordable housing. Yes, that is one thing that I'm hearing. I have myself done some reviews for builders on their plans in Kansas City to find out what it would take to pass the 2021 IECC. And those costs of doing that ranged from $1,500 on the low side to $8,000 on the high side. I've heard from other energy professionals who are doing the same thing, and the average is about $5,500 per plan to be able to meet the 2021 codes. And then they're saying, well, that makes the houses more expensive, and we're doing away with affordable housing, and people won't be able to afford it. Well, the answer to that is that this $5,500 in additional cost results in $500 to $600 a year in savings on energy savings. And when you look at that on a monthly basis, the increase in the mortgage cost is less than the savings on the utility costs. So instead of sending the money to the utility company, you send a few extra dollars to the mortgage company and you keep the rest. as extra income, because you now have you have additional money because it doesn't cost as much to pay your utility bills. And so that can go into the new fishing boat or whatever you want to do. Date night once a week. We've got, so the math bears out that it costs less to live in a home that's meeting the 2021 IECC.
Also, there's rebates available too if they build an efficient home that helps offset the $5,000 or whatever it comes out to be.
That's true. There are $2,500 and $5,000 tax credits available for building highly efficient homes that wouldn't be terribly hard to meet if they're already meeting the 2021 IECC. So the builder could save that $5,000 right off the top, and then it won't cost anything. Yeah. So I did go through the HBA's list of here's all the increased costs, and they were coming up with like $30,000 additional cost, something close to that. And really all of that cost was in building a double wall on the outside to handle the R30 insulation, which, as I already told you, there's other paths that can be followed and other options that can be used. So that's not a requirement of the code, and it's a ridiculous cost that they're putting out there. It doesn't reflect the reality that people are seeing who are actually evaluating the actual plans that are going to be built. What about quality control? How is KCMO code staff being trained to verify compliance, or are they? Yes, and that the Metropolitan Energy Center and the city of Kansas City, Missouri hired me and to provide training to the code officials, and I have been training them. We've gone through several rounds of training. And then they're learning all about the 2021 codes. They are learning how to verify the compliance, but they're also learning where they can find third-party verifiers so that they don't have to get the certification and pay for the equipment and all of that. As Ken said, the IRA, the Inflation Reduction Act, also has monies available for jurisdictions that adopt the code to be able to help them get trained and staffed up and get any more equipment they need, and do all that. So they are taking advantage of that and working on a grant application right now to be able to get some of that money to help shore up the codes folks, the KCMO code staff. Has the city made any commitment to implementing and maintaining quality control inspections? Yes, as they get trained. I've trained the heads of the Kansas City, Missouri residential codes department, and they are very committed to making sure that the inspections happen. They are understaffed at the moment, and they don't have all the knowledge they need, but they're working toward it. And that's part of where those IRA funds would go, is to help them with staffing and getting built up to be able to handle all of this. And that's one of the reasons they delayed the implementation of this to July, is to give them time to get up to speed and to get staffed and to get trained and to have all the information that they need to be able to go out there and inspect and verify these things. How would a builder figure out which path to compliance is best for their project? That is a very good question. If the builder doesn't want to follow the prescriptive path, all the other paths require that a simulation be performed, that the plans, the energy use be calculated. So there has to be a computer simulation program put in place or used to determine how much energy this house is actually going to use. So to do that, a builder generally works with an energy professional like a HERS rater, home energy rating system HERS rater, and that person can evaluate all the different paths and say, okay, you can comply with this path if you do these things, you can comply with that path if you do those things. So they can play all the what if games. They've got the software, they've got the training, they know how to do the energy models. And so I would tell a builder, find yourself an energy professional and have them help you determine what you really need to do to meet the 2021 codes. The builders who have been doing that have been pleasantly surprised that they are closer than they thought they were to being able to comply for less money than they thought it was going to be.
It would be a good idea for the for us or the city or somebody to do a test analysis on a home where they analyze those 7 uh, uh, different paths and see what the cost would be, and that would be very informative for the builders if they could look at something like that.
Mm-hmm. Absolutely. The energy code in Kansas, Kansas has home rule as well. So the different jurisdictions have different codes. Lawrence, Kansas has been very progressive. They've been using, I think they're on the 2018 right now. And Overland Park and unincorporated Johnson County, Kansas are, and the Kansas City area, they're all considering going to the 2018 IECC. They're looking at what Missouri is doing, Kansas City, Missouri, as well to consider 2021, but I think they're leaning toward 2018 at this point in time.
Thank you.
Mm-hmm.
Charlotte, do you think you'll be? Do you think you will be approached by the HBA to do a seminar for the builders locally?
Yes, I have been doing seminars for the local builders as well. I have done them through the Johnson County Contractor Licensing, and then of course they have been invited by Metropolitan Energy Center to join those sessions as well. And there's been several builders in there. As far as being invited by the HBA, I have not been invited by the HBA, but the HBA does, offer training sessions, and I'm sure that if I approached them and said, "Hey, can I do a training session on the 2021 IECC for the builders?" They'd probably say, "Sure." So that's an idea. We could do that and see if we can get one at the HBA. But I have had several builders take the training through the Metropolitan Energy Center as well.
How have the builders responded during the training?
The ones who come really want to learn about it and want to understand what they're getting themselves into, and they've been pretty open to the ideas, especially when they realize that they don't have to make that big of a change as what they're being told they have to do.
Are all of the homes, do you think, going to need an air infiltration test with a blower door or how do they determine that they're less than 5 air changes or 3 air changes per hour, which seems like already a very high number?
Testing is required, yes, for air infiltration, duct leakage, and mechanical ventilation airflow. So the testing is required on every new home, and the air changes per hour is at an artificially induced pressure. It's at 50 pascals of pressure, which is like having a 20-mile-an-hour wind on all parts of the house. So when you have 3 air changes per hour, that means the air in the house will change out 3 times each hour, but only if there's 20-mile-an-hour wind on all parts of the house. So that generally relates to a real natural air changes per hour, much lower than that.
I imagine that blower door sales will increase again.
Likely, yes. Blower door sales, yep. Mechanical ventilation sales, and these tax credits that Ken was talking about. I think it was Ken. Somebody brought up at the $2,500 and $5,000 per unit. Those require Energy Star certification or Zero Energy Ready Home certification, which means that that requires even more extensive testing and oversight. And so we're going to see an increase in work for energy professionals. We're going to see an increase in testing and energy efficiency. So yeah, we probably will see an increase in blower door sales.
I think this is going to require a dramatic change in the nature of home builders. Because
shouldn't the more progressive home builders aren't that far off? It's the ones.
That's what I mean.
The
progressive ones will survive, and the non-progressive ones will not survive. They won't be able to pass the test.
It's it's already known that if we have poor energy codes, builders tend to go there because they can build worse houses and it costs them less. So it's possible, and I won't say this is happening for a fact, but it's very possible that outside builders of other places want to come to Missouri if we have this pass with this House Bill 580 so that they can build crappy homes, less expensive, and then of course they don't have to live in the homes or even be in the state to live with the results of all this. So
yeah, one of the interesting things that I found when I attended the public testimony for that was the gentleman who introduced the bill is a home builder, and the gentleman who chairs that committee is a home builder, and both of them said that their houses were very highly insulated, and they have used ground source heat pumps, and they made sure they were built very tight and energy efficient. And if people want to do that, there's nothing stopping them. They just can't require it in the codes. So I thought, well, if it was important for your own house that you do these things, why are you trying to keep anybody else from being able to have that nice of a house? It doesn't make sense. They're saying it's too expensive. Well, if it was too expensive, why did you do it? It's too expensive and doesn't, because they're also saying it's all arbitrary and doesn't make sense from an energy perspective. Well, if that's the case, why did you both do it in your houses? And now you don't want other people to have it. It's just
obviously they figured out it does pencil and pay to do it, or they wouldn't have done it.
They wouldn't have done it for themselves.
They probably didn't want to be uncomfortable, have leaks, have an unhealthy interior environment. Indoor air quality was probably important to them. Filtration, all the things that we really want to have happen in every home.
And the builders that are from Kansas City and that live here and build here, we have an unusual environment from a lot of places where we don't have a lot of production builders that build the same house over and over and over again.
Yeah.
We have a lot more custom builders that they build just a handful of houses every year. They don't seem to have a problem with this. They're okay with it. They're finding out what it's going to cost. They're seeing that it makes sense. The people that I think are pushing this bill are the big production builders that want to come build schlock in Kansas City or in Missouri. Because they can't do it in their own state. They're coming from Texas, and they're coming from Arkansas, and they're coming from places that have Oklahoma that have more strict energy codes, and they're wanting to build a whole bunch of houses in Missouri where they can build them cheap and fast, and that seems to be who's pushing this bill through.
There's one other thing that we've experienced, because we've been in this a long time, both Charlotte and I, 43 years now in this energy efficiency business. And one of the things that we've had happen over and over is people from California or the East Coast will say, I'd like to see a selection of Energy Star homes, or I'd like to see some homes that meet some kind of efficiency level. And then basically what we have to tell them is, technically there are hardly any. There aren't any. So they are always astounded and saying, well, we were mandated, like in the state of Washington and Oregon, like mandated that we have to do this. So I also tell us how much window area we can have because of the insulation and all that, so cold or wet or whatever. And the states enforce that. And then they come here and say, what are you doing? And build anything you want. And the other side of that coin too is that if this law passes, if they make it a statewide law, and I can't say this will happen for sure, but it's very likely that insurance rates will jump up quite a bit because insurance people will say, well, if they don't have to be inspected and they don't have to meet any codes in particular, then people will just do whatever. And so now our risk goes way up. So I don't think they're going to wind up getting the savings they think they will, because they save on the cost of building a home. Their insurance as a builder probably is going to cancel that out, but we'll see.
Well, one reason that Kansas has more stringent codes now, and thank you, Dave. David Roberts says that Leawood, Kansas uses the 2018 IECC. One reason is because they hired some code officials from up north, Minnesota and places like that came down to Kansas City and went, what? Wait a minute, you're doing what with your energy codes? And so they started implementing more requirements in the energy code, more stringent energy codes in Kansas, because they knew about the value of doing that from where they came from. And so we're seeing that, but Missouri's trying to go backwards.
Are dimmers required on LEDs as well?
Yes. All lights. Dimmers or occupancy sensors, or another means of automating the on-off in main areas of the house. Yeah.
Charlotte,
Yes, Jerry.
with regard to HB 580, have you seen any similar movement in Kansas toward that kind of a legislation?
I have not, but I'm not really that active in politics. I just jumped into this one because I couldn't believe these 5 items that they're trying to push across the state.
Sure.
So it could be, I don't know. The Sierra Club stays on top of that stuff. And so that's kind of where I would go look and see if there is something like that brewing in Kansas.
Okay.
Did we address all the questions, Craig?
Yeah, I think so. Right, we have.
Oh,
Yes,
go ahead.
David Mitchell.
Yeah, just, so is there any clarification, any further clarification on, action on HB 580, beyond what has been provided, or?
It just shows that it's going to be discussed in the executive session on Monday.
Oh, okay.
By that committee, the legislative committee.
Oh, and then from the legislative committee, it would go, we sort of have to assume that it'll pass and that it'll go to the
House to
the
vote.
My
House.
assumption it'll go to the full house, and then then it's time to rally to your state representative and say.
And then, well, this is terrible, actually.
It's terrible.
This is, you could really have a long conversation about what's motivating these particular people, and whether it's a general resistance to the necessity to reduce our footprint, or whether it's homeowners, or whether it's a direct response to the Inflation Reduction Act. It might be a combination of all of those, but this is terrible. This is not.
One thing that came up a lot by the committee members, or one particular committee member, was he kept saying it was a money grab by Kansas City to adopt the 2021 IECC because they want the IRA money. My response to that is no. The change to the energy codes has been evaluated and discussed and analyzed for at least 2 years now in Kansas City, Missouri. I've been part of those hearings. I've given testimony. I've done research. I've provided it to the code officials. Actually, it's been over 2 years in discussion and in committees and doing all this for the codes department to decide what's best for the Kansas City area. And then, the IRA money is icing on the cake. Obviously, that helps us implement that. But they decided on the 2021 IECC before that even was a thing. And so it's not a money. And besides, so if Missouri says, well, we're not going to allow this, I don't think the IRA is going to go away. I think it'll just be that Missouri taxpayers will be paying their taxes and not getting any benefit from that.
Most likely is that the state will be, the money's going to come from the federal government, and it's already passed, so it's going to happen. So what will happen is that it'll be divvied up between 49 states, and Missouri won't get any, but we'll still have to pay for it.
I think one thing we have to understand is that this movement at the state level with regard to the codes is not a standalone issue. It's part of an overall approach at the state level to more forcefully control all cities across the state. As an example, and there are several things, but as an example, we know Kansas City has no home control of its police department, whereas in an election a couple of years ago, city of St. Louis was allowed to have home control. There is now talk of legislation at the state level to rescind what the voters approved and reinstate state control of the police department in St. Louis and other major cities. So I think we have to see this as part of something much greater than just energy codes with regard to the true politics that are happening here.
Yeah.
Well, yeah, the same thing happened with, I got a letter to the editor published Thursday this week, and I pointed out that the legislature negated minimum wage increases in Kansas City and St. Louis, and they did that in 2017, and it took an initiative petition passed in 2018 by 62+% to modify the minimum wage in Missouri, and that was again an effort by the legislature to attempt to control what Kansas City and St. Louis were doing. So Jerry's right. There's this very destructive dynamic going on between the legislature and Kansas City and St. Louis, for sure.
And I have also seen some movement toward making it a lot harder to get something put on the ballot by individuals. So,
What's going on right now?
yes.
Yeah, that's was the reason for my LTE this week, and so.
I think the most amazing part of all this is that what they're doing from some of these rules is pushing everything backwards, but we're moving into the future, whether they like it or not. So, I mean, do we want to go ahead and prepare for the future, or are we going to just sit back and wait till the future happens, which we could do? And then when it shows up, which tends what we do in America is we got to do something about this. It becomes an emergency. Whereas right now we can prepare for more expensive energy and electric cars. And yes, we don't have to necessarily say everybody has to buy an electric car, but we certainly don't have to make it hard for them to get one, or make it where make it illegal to have an electric charging station in your house or something like that. Because why? Really, when it gets down to it, are we really going to go backwards? I guess. I don't know.
We're not going to stop climate change by making it illegal to have more energy codes, having
Right.
more stringent energy codes.
No matter what mankind thinks, we can't control the weather, we can't control the climate, and it sure looks like we're destroying our home, the earth, more and more. But
I want to thank Charlotte for wonderful presentation, and also for her letter that she wrote and sent it out to all of us. Did you send that to the rest of our membership, the letter that Charlotte wrote?
I did not receive approval to do that, so I just sent it to the board.
Oh, I think that should go out to all the people on our mail list, and because I think it was very good. And I went ahead and wrote to my legislators, or two of my representatives anyway. So I hope they pay attention. I haven't heard from either one of them back. I did that early last week, earlier this week, but I haven't heard back from any of them. So
I'd like to point out that we have the Sierra Club who can lobby, and we also have Renew Missouri Group. And I was going to say this, and since we're still talking, in case everybody wants to leave, we understand. But I got a message I sent off to James Owen, who's the executive director of Renew Missouri. And I said, what do you think about 580? And he gave me the message back saying, I'm afraid that it'll pass, and probably pass in the House. And so, but it has to pass the Senate. And we won't see how this is going to, once it gets past the House, it's going to be really raised up in terms of visibility, because that's how it happens. And then we'll see what the response is from the big cities and all that, so whether they're going to just sit back and let this happen, or they're going to, they can lobby.
yeah,
So what we do is advocate
And
Educate.
and
and educate.
And I have a question about getting back to the home structure. What are the thoughts around what the Stitt company does for return air, where they eliminate a lot of the return ducting and just pull air out of rooms and let the house itself be the ductwork?
Well, what they do is they have what's called a central return, which is
Yeah.
a large return in the middle of the house. And then they have pressure relief systems. Do they use jump ducts, or do they use transfer grills, basically?
transfer grills.
Yeah,
If
transfer
the doors are
grills.
closed. Yeah.
Yeah, that allow the air. So the air from like a closed bedroom or something to come into the main body of the house.
So that those things are still allowed then. It's where they just respond to the vacuum that's created by the furnace. And
Correct. Yes, absolutely. A transfer grill is an excellent means to allow that pressure relief. It's
and
not,
cheaper, I would guess.
yeah, you're not forcing the conditioned air with a air handler fan through that part of the house. So yes, those work just fine. It is a good idea for the transfer grill to be blocked at the top and at the bottom so that it just is that part of the wall. But yeah, that's still allowed, and that's not causing duct leakage because it's not a duct.
Right. However,
Just pressure relief.
if you use the house itself, part of the cavities and stuff is your return. Charles says almost impossible to get those airtight. This is another reason why we're trying to get ducts to be good, because that way you have air making it to the far ends of the ducts and actually coming out of the register.
Now that's another big change that the House Bill 580, if they require that you allow building cavities to be used as ducts, they don't say return ducts. It's been against the code in all across Missouri for a number of years now, decades to use house cavities as supply ducts, but House Bill 580 would require that be allowed now.
So that means if you're doing both of them that way, then they're just going to find the closest return path to each other. They're just going to circulate a little circle.
Yeah, you're going to have very, very uncomfortable houses that cost a lot of money to heat and cool.
Well, thanks very much, Charlotte. That was great. Fantastic. And I'm gonna make sure I let a few people know, but they didn't show up to this, but tell them that it's on the website, that they can go look at it on the website. So let us know when that happens, okay?
Absolutely.
One thing Charlotte could have said right off the bat is that she teaches an 8-hour course, which she condensed into this. We're running over time wise, but she's trying to squeeze 8 hours worth of training into about an 1-hour session.
Yeah.
So she did a good job. I thought she did fantastic.
Yeah, I was amazed at that you got as much in it as you did. It was great.
One of the things we hear over and over and over is builders that actually start working with third-party verifiers or inspectors. They find out that they find things that could cause them to have to come back and do what they call what is that? The return. There's a term for that.
Callbacks.
Callbacks.
Yeah, they say that their callbacks decrease and that their referrals increase because now people are happy and comfortable in their homes. Their utility bills are low, and so but if they're uncomfortable in their house, they're going to be contacting the builder, and so the builders who do this say that it's well worth it for them because their callbacks have dropped like crazy and their referrals have increased, and so it saves them money.
And they have happy
Charlotte?
customers.
Yes.
Charlotte?
Yes.
Yeah, one thing I would be interested in is in one or more of the slides that you provided, it showed generation of mold as a result of the poor quality standard that was employed. I would be very interested to see if ACEEE or someone else has done a study with regard to the insurance liability impact of that occurring. If there's a new house that's generating mold, is there an insurance liability issue there? And I don't know if that's been studied, but I think it might be worth looking at.
We have looked at $1 million homes that have insulation missing in cavities and
Sure.
only poorly done in the ceiling. It's very common to see insulators go up the attic access and blow insulation for the first 10, 15, 20 feet that you can see when you look up through the attic hatch, and then not worry about blowing the insulation all the way to the far ends of the house and stuff. They don't even worry about getting any there. Because the inspector, and that's why we ask our raters and people. We don't have raters anymore, by the way. We are simply education now. But back when we had home energy raters working with us, we made it very clear that they had to go in the attic and walk past the middle part of this house and see, does it actually extend to the far end? Because you can go in with the infrared and look and say, oh my gosh, there's just not any insulation at all at this last third of the house.
Well, you saw the picture with the frost and the water inside the house.
Yes.
Yeah, that's just a precursor to mold and moisture issues, and
And
so but yes, I will look that up and see what I can find, because I know that.
I mean, if there is a study of that, and I'm assuming it would show a negative impact on the builders, in terms of callbacks and possible litigation. That's something that they ought to be educated to with regard to including that as part of their cost estimate,
Yeah.
Mhm.
or real cost, I should say.
Just because they push codes backwards doesn't mean they limit their liability. If anything, they're increasing their
Sure.
liability by orders of magnitude, I think. Again, my opinion.
Absolutely.
Very good.
All
All
right.
right.
Well, thank
thank
you
you,
all for
Charlotte.
coming and spending your Saturday morning with us.
Yeah,
And
thank you, Charlotte.
Gotta
Thanks
go.
for
Thank you,
Thanks,
Charlotte.
Charlotte.
Thank you,
all.
HRES.
All right. You're welcome. And thank you again, guys. We will put this on the website as soon as we can.
Okay, great.
All right.
Thank you.
Bye-bye.
Bye-bye.